Okay, I'll use. Good afternoon to all of you. Welcome to IIT Madras. It's my pleasure to have this interaction with you and talk to you. Yeah. Oh, that's still going on. Sorry. I just close it. Okay. We always should be doing multitasking these days. So when one window is open, second window, something should be going on, is the expectation of the software now. Sorry, I didn't realize that. So again, welcome to IIT Madras. I am from the Department of Chemical Engineering. I have been at IIT Madras since 1996, so it's been about 30 years. And my education also has been in chemical engineering throughout. But I have worked on many of the problems which interface with other disciplines. And so, as was mentioned by Chetna, that I work in the area of polymers and what are called complex fluids. In the video that was running, you saw toothpaste, right? That's a very common example of complex fluid because it seems to be solid, that it holds the shape of a cylinder, but it's very easy to, squeeze out and then flow within our mouth. So specific interactions have to be managed to make such complex fluids. And they, of course, our body is made of these. And so that's why I'm also part of a center which is called Soft and Biological Matter. Many of these materials are soft and they have big relevance in biology. So that's just to give you a sense of interdisciplinary aspects that are also involved when we do research. But today's focus will be on the Department of Chemical Engineering and its curriculum, what it offers to undergraduates. And our hope is that while they do this degree in undergraduate chemical engineering, which focuses on the historical field of chemical engineering, they get into a world which is very relevant today, and they can seamlessly transverse different types of problems based on what is required. So basically, the idea is to take raw materials. So in case in the video I highlighted with the example of a toothpaste. So what is toothpaste made of, right? So the raw materials are involved. They have to be processed. So a chemical engineering process is central to what we learn as an undergraduate student. Process is too complicated. We break it down to smaller operations. So an individual operation in which mixing can be done, heating can be done, reaction can be done. So therefore, though in simplistic term, we take raw materials and get into a product, and that's what chemical engineers do. But we do this by designing processes, operating those processes. But as students, before we get on to learning about the processes, we have to learn the operations. And so we learn individual operations as students first, and then finally learn how to design a process. So therefore, there are millions of products. And again, in the video that was running, you saw the examples from day-to-day things like toothpaste and petrol to which other day-to-day thing these days is, of course, semiconductor devices, and to various things which are used in much smaller quantities. Pharmaceutical is one example. If there are very specific targeted drugs, or we also have flavors or fine chemicals which are also used in very small quantities, but again play a very crucial role. So very large quantities like fertilizers and petrol, but very small quantities which are sometimes involved in fine chemicals and pharmaceuticals. So the product range is quite vast. Also, chemical engineers deal with producing a single chemical, but also the product. So toothpaste is an example where it's not just a single chemical, but various chemicals have been assembled together. And so we learn not only to talk about how to make one single product like ammonia, let's say. Historically, we will say sulfuric acid is one of the most oldest. If you look at history of industrial chemistry and chemical engineering, sulfuric acid is the one which started getting produced at very large scale. So therefore, from there on to, all the single chemicals are involved, but we also make petrol again, which is a mixture of chemicals, toothpaste, which is a mixture of chemicals in different phases. We have solid phase, liquid phase, we make ice creams where it's a mixture of solid and also air, right? So there is some amount of always air which is present in ice cream, which gives us the eventual feel when we say it's a rich, creamy ice cream. So therefore, these are some of the sectors which are involved through the examples that I have given. And generally, the way we can learn about how to look at these very complex processes, these 4 stages. So first is basically foundations, and that's common to most disciplines of engineering. The second is where it becomes little more specific to chemical engineering. Chemical engineering is one of those branches of engineering where molecules and molecular scale still remains extremely relevant. So even if we are doing things at very large scale, the chemical transformation happens at small molecular scale. So nitrogen and hydrogen react to give you ammonia. This reaction happens at molecular scale. So we as engineers, even though we are producing tons and tons of these, we still have to understand how is it that nitrogen and hydrogen can react to give you ammonia. And one of the things that I'm giving this as an example because it's also a very energy consuming reaction. It's fairly expensive to get ammonia. And today's world where we are now looking at sustainability, energy efficiency of processes, is it possible to make ammonia with much less energy? So chemical engineers of today are saying that, okay, same ammonia that we need, but can we make it completely differently? So therefore, we have to worry about the molecular scale. And so the second year, therefore, looks at energy, fluid mechanics, thermodynamics, and then the year 3 is where we start getting into design aspects and more computational, and many of the labs are also there. And then finally, 4th year either contains where we take electives, which are from various different branches of chemical engineering, or we can also do a project. And in terms of minors that we offer, so polymers is one minor. Systems engineering basically encompasses an important aspect of chemical engineering because controls and overall process being under control is extremely important. So we look at a process as a system, and therefore analysis of a chemical process and controlling it is very important. In this, we share some of the basics with, let's say, electrical or mechanical engineering. There, it's a device or an equipment which needs to be controlled. In our case, it's a chemical process which needs to be controlled. So systems are slightly different in each and every discipline, but fundamentals may remain same. And the other, of course, minor is related to energy and environment, given its centrality from a societal point of view. And then soft matter, which I've already talked about, given that many of the materials in our personal care, personal space, as well as healthcare space are these materials. And chemical engineers play a strong role in this because molecular interactions are the ones which, again, decide what's the nature of these materials. So a shampoo gives you, a creamy shampoo, a shampoo which is more runny, a shampoo which is phase separated. All of these are happening because of molecular interactions. So again, these are the materials which chemical engineers play an important role in designing and manufacturing. And we have an interdisciplinary dual degree program because as part of chemical engineers, you learn sufficient background in terms of systems, computation, and the basics of transport phenomena and thermodynamics that you can then look at cyber physical systems as a dual degree. Yeah. Yeah. Yeah, I'll come to that. Yeah. So CO2 sequester, these are some of the other examples, environmental, sustainable engineering technologies. These are just some research snippets, which again I have highlighted. Maybe I think I'll go to the next slide and then explain it. So these are sort of broad 6 areas in which faculty members of our department are involved. And again, these are something which you would say are important for the future. Catalysis and reaction engineering is completely focused within chemical engineering. Many of the other areas we share with several other disciplines. They can have interdisciplinarity. Catalysis and reaction engineering is, again, has an interdisciplinary interactions with chemistry. In reaction engineering, we have also a field, let's say, for example, process intensification. And this is something, again, a future chemical engineer has to worry about. As the term suggests, whatever process that is being carried out to produce a chemical, can it be intensified? So I talked about several operations make a process. Can I combine 2 or 3 operations in one? Can I, improve efficiency by combining or intensifying operations? And so that's also a very active field of study given our requirements. We also work on environment and sustainability. Systems engineering I already talked about. Bioengineering is also something which many chemical engineers work on as a research area. And so we do have electives also which are taken in the 4th year, which will encompass examples from bioengineering. During some of the other courses in the 2nd year or 3rd year, again, many of the faculty members will take examples of these areas to make it more interesting to students to relate to current challenges that society is facing. And so next 3-4 slides are just to sort of give you an idea of, again, the kind of work that a chemical engineer does, given that this is news about our department faculty. So for example, this is related to a center which is about metal air batteries being set up. Then this is basically where data science can be used for sports also. So variety of different options are there. This is basically interaction between CRICStats and Professor Raghu. Then low-cost chip-based device, which is for, again, measurement, in this case, antibiotic susceptibility testing. Of course, plastics and its effect on environment, we are all very well aware. So therefore, bioplastics development. And then even if the waste that's there, what to do with it. So waste to fuels, from anything to fuels is what Professor Venu's group does. And then overall in terms of climate change also. So what is the role of human activity in shaping clouds and climate? So Professor Ravi Krishna, in collaboration with others, did this work last year. So therefore, this gives you a snippet of some of the things that chemical engineers are doing and are worried about. In terms of recruitment, so many of our students go on to do further studies. Many of them do startups, so those are not listed here. But this lists basically the employers, the fraction of students which seek employment. These are some of the examples of companies which regularly recruit from our department. And what I was showing you in the beginning is a full, actually, course which is intended for school students, and it's there on YouTube. So it gives you a fairly broad idea of what is involved in chemical engineering. There are 20-odd videos, each 15 minutes or so. And you can see some of the topics: reverse osmosis, making jaggery, detection of analytes. So there are various topics that are discussed, and these are some of the initial. I've just taken a snapshot of the initial window. Later on, we also discuss computation and use of AI, ML in chemical engineering and so on. So those of you who are interested in further details, please feel free to look at some of the videos here. And that's where I'll stop, and then I can take questions.
Yeah. Professor,
yeah.
I'm an alumnus, I told you.
Yeah.
But every parent's #1 question for the last 5 years is, if I take chemical engineering, how much chemistry do I have to study as a child? If I don't ask this, everyone will ask. So I'm just going ahead and doing this.
Yeah. So as the name suggests, chemistry and chemical engineers are closely related. And I have already sort of clarified that this is one discipline of engineering which still keeps molecules at the center. And chemistry is a science of again, atomic and molecular scale. So therefore, compared to other engineers, the emphasis on chemistry is definitely higher in chemical engineering. But if you look at the number of courses, we can quantify this by saying, how many courses does a chemical engineer do in chemistry? So it will be 3 as opposed to 2 for others. So that's the level of sort of difference that you will have. But of course, we also have in the latter year, we will have a course called reaction engineering. So it implies that we are still focused on reactions, but this is no longer looking at from the point of view of a mechanism or doing it in a lab scale, but we are looking at engineering of chemicals at very large scale. So the focus immediately becomes on the reactor instead of the reaction itself. So that's why we call it, the disciplines are called reaction engineering. So if you say, is chemistry involved there? Of course it is involved. But the focus is on how does one carry out reactions at extremely large scale. And when you want to do anything at large scale, those of you, of course, from an example in kitchen, we can sort of see that, when we are heating something, the bottom is likely to get burnt if we don't do mixing effectively. And if I do something in a small vessel as opposed to a larger vessel, I have to pay attention to what I am doing in the kitchen in terms of stirring and mixing. So this is a basic idea which is also involved in when you do chemical reactions at small scale versus large scale. When I said mixing, heating, cooling, these are all things which are, when you do at industrial scale, one has to look at the engineering aspects of it, which a chemist may or may not worry about as much. So I don't know if I have sort of answered the question, but if there are some aspects of that question, I'll be happy to answer. In terms of cyber physical systems, I think we will need somebody else to answer that, because it's a dual degree program where other department takes care of it. So it's better that the dual degree department mention that. Yeah. Huh. Yeah, so generally I would say it's as good as any other discipline. And I can say that it's quite good, right? And it's better than many others. So, but generally, I'm also speaking here as a representative of IIT Madras, where each discipline is important. So that's why I want to give you an answer, which is somewhat more, But basically, we have not found people struggling to get jobs. That's the best way to put it. In terms of opportunities, they are in industry, they are in academics, for MS and PhD, they are in MBA, they are in startup, all the different disciplines. So I don't think there is ever a struggle to get placement and things like that. Internships is also easy to come by. So I think the percentage varies, but maybe sometimes it's 40-50%, sometimes it's 60%, sometimes it's 20%, depending on what class you are looking at and what year you are looking at. Right. Yeah. So so when let's say you do manufacturing, right? So if you are designing, let's say the chips, right? So then it's more of electrical engineering. So in India, for example, so far if you look at semiconductor in the past, many design centers of companies were there. So they would be employing largely electrical engineers. But now that India is talking in a big way about manufacturing of these chips, so then you will have a larger fraction of chemical engineers applying. And so, for example, if you look at, let's say, Intel as a company, right? So Intel employs maybe chemical engineers in a smaller number, but Intel's fabrication is all done, let's say, on a company which is Applied Materials. So Applied Materials will make many of the equipment using which Intel will make chips. So Applied Materials will overwhelmingly more number of chemical engineers will go in. Yeah. Yeah. Yeah, so it will be much stronger role for chemical engineers, processing and yeah. Also, in many of these plants, there will be requirements in terms of, let's say, water itself, right? So, in all of semiconductor manufacturing, water is a very critical element, clean water. So, even to process water to get to a requisite, deionization, all of that is a chemical process. And then effluents that are there that have to be also treated. So, therefore, that's again a chemical process. These two are exclusively chemical domain only. But within even the semiconductor manufacturing operations, we again look at it from the same point of view, that there is a process, there are several operations. So, chemical vapor deposition, for example, is a process by which chemicals are deposited for a semiconductor device making. So, again, chemical engineers play a huge role there. So, one of the videos in that YouTube list is related to chemical vapor deposition and things like that, to again give you this idea that chemical engineers will play a good role in terms of semiconductor manufacturing.
Just want to add on to that. In 2024, I had been to a conference in Mumbai, and there was one of the people who was leading the semiconductor plant development in Gujarat. Not sure which company he was from, but he was a chemical engineer. So he was the head of the plant itself. Like, he was getting the plant developed. So he was a chemical engineer. Of course, he's had his own journey over his large career to end up in that place. And I was also in the chemical engineering placement team. So if there are any placement related questions, I'll be happy to take some of those alongside Professor, of course.
Yeah, so generally, one of the things that I would say is if a student is keen, let's say, or if an individual is keen on remaining in core, it's easy. Okay, because many of these things are, and at that age and with the peer group, there are just too many options. So many times, for example, students have come to me by saying that, look, if I get this admission in this university for MBA, I will go. Or if I get this admission, then I'll do PhD in chemical engineering. So that's the kind of confusion they have. So generally, my advice is, why don't you think a little bit and then say, stick to one path. You will definitely get opportunities there. But it's the age where all these 4 or 5 options are there. And so individual is likely to be saying that, okay, if the first step here is slightly less salary, and here if I get more salary and 5 of my friends are going here, then what should I do, right? Those are the questions the individuals are, But I have not seen anybody who says that, look, I wanted to do chemical engineering, but I waited 6 months and I didn't get anything, therefore I am doing this. No, that just doesn't happen. They are already, in their 7th semester, they've already made up their mind that 7 of my wingmates are doing this, so I'll do this. In other case, no, I want to do this, therefore I'll do this, or 5 of my other friends are doing this, or my brother, sister did this. So it's push and pull from various angles. And it is all happening in those 6, 7 semesters. Not because I wanted to be in core, I didn't get an opportunity, I'm giving up and joining. That I have not seen.
There is ample opportunity, in fact. In my placement head year, there were students who came to me complaining that, hey, there are not enough core jobs. And then companies also came to me saying that, hey, we want more students. And I was like, both cannot be true. Only one of these statements can be true, right? So there are enough jobs. And ma'am, personally, I would say that let's not think about the degree going to waste if they pursue something else.
Right,
let's think about that later. Yeah. And I also want to say that we have faculty working on AI and data science within the department. So will you call them non-core professors? Not really, right? They're still chemical engineers. So
yeah. See, actually, one of the things that I can say, for example, from my own experience this is in 89, when I was graduating. So came March, became March, and I had applied for abroad, MS, PhD, and I had got rejects by then. right? And I had appeared for placement also, and I had not got. I had some 7, those leading time, No-Sill, Reliance, they were all big companies, and I had got reject from all of them. And I was here in March, trying to say now what to do. So I just visited my parents, told them that, look, within IIT, there is a project position available. They'll give me some X thousand rupees a month. So I'll do that project. I'll apply again next year, okay? Because I'm very keen that I want to do PhD. And so don't worry about it. It's not because there are no, if I keep on trying job, I'll get it. But now I want to stop that because anyway, that's not my interest. I've made my decision. I'll do this. It so happened that when I came back after this visit, 1 week later, I got 3 offers. The 3 which were remaining, they all came. And also the 7th industry also gave me an offer. So such things happen. So, but if you ask me in February, March, at that time, I will say, oh, confusing. Some people are saying do this, some people are saying do that. And so in my batch, there were people, that was the beginning of software era. So there were few people who had already taken software jobs. So I would have got advice that forget about all this, take the job which is available. Citicorp is coming, they're going to hire some software jobs, why not take it? And it's not a bad thing that is done also, right? So overall, as I said, as an institute, we are saying that we produce individuals who can think, who can analyze, who can, function, who can be professional, and who can, deliver for the society. So that's the bottom line.
I have friends who are, like you said, right? Said that this company pays me more, so I'll become a software engineer or a banker, whatever. 2 years, they're like, I can't do this. I want to do core chemical engineering. I will go back, meet my professor, do something. There is also the other side where someone says, I want to do core. They do core, and then they're like, I don't want. I'll do software or whatever. I think we also have some faculty who are software engineers, so things turn around all the time, ma'am. Yeah. It's unfair to expect that, hey, whatever I'm doing, I mean, I work in marketing, okay? You are saying that you don't want your son doing software engineering. I definitely don't think my mother would have thought I'll become a marketer after doing my BTech without doing an MBA, right? It's completely unexpected. I think at the end of the day, what I'm doing is something I want to do and what makes me happy. And that is what is important to me, right? More than pay and other things.
Yeah. Yeah, I think he has a question, yeah. Huh. Okay, so I get this question asked again, and so it's very, I should say 2 things. One, I did this decision 30 years ago, and I have no kids, so I didn't have to make this decision at a very close level, okay? So therefore, I'll qualify. Whenever I get asked this question, I say that I think you have to go by your hunch. Also, don't try to optimize between n number of things. It's okay to say, I like, this discipline. Wherever I get it, I'll take it. Or it's okay to say, I like this region of my country. I want to be in this region. Whatever branch I like, I'll get it. It's okay. Let's not be, because the options are, just too many. You are going to make your life miserable by, trying to think which is good and which is bad. So this is only answer that I can give you. So narrow down from which you can choose is what I would say. In the end, the individual will decide the path. We are only giving the initial steps now, right? So that we will ensure will be, as good as our efforts will be towards that. Yeah.
So we've done nearly 25 events in 5 years. So if you ask me, I'll say come to IIT Madras.
Yeah. Versatile. No, so maybe the role of yeah. So versatility could be one of the aspects is the fact that we still go back to the molecular scale. So if you look at now, let's say biotech, where drug design involves, how does a drug exactly go in the biological cell, interact and do its job? Chemical engineers can do that job also. At the same time, a chemical plant at a very large scale is basically a structure. right? So I need to understand mechanics of how a big column can be erected, how it is. So therefore, now I'm talking the language of like a civil engineer. And then pumps and compressors are involved, which a mechanical engineer will also work with. So therefore, when we look at the overall, range of subjects that we are, interested as an undergraduate student, will be many of these. So there is some overlap with many of the disciplines. Yeah, so and it's again, since I'm here, yes, it's possible. So chemical, we've had reverse also, people who do degree in mechanical engineer, but then they end up doing research in chemical engineering or being in a company which is predominantly a chemical manufacturer. And so similarly, chemical engineers can also go to the other disciplines. So it again depends, many of these things depend on what is the interest of the individual. Yeah. Yeah. But at a sort of definitional level, given that we have to be interested in molecular scale, quantum mechanics and physics is also equally important in chemical engineering. And then given large scales are involved, engineering of large scales in terms of structures, mechanical properties, fluid mechanics, which let's say an aircraft, aerospace engineer is very important to understand fluid mechanics and structures. But similarly in a chemical plant also one has to understand that. I'm not saying that it's the same emphasis as other disciplines, but those concepts are required. Yeah.
How much like it is more involved?
Sorry, I'll just, yeah.
How much this curriculum is like more involved in CFDs?
CFD is computational fluid dynamics, right? Yeah, yeah. So CFD is again an important tool. It's basically doing fluid mechanics using computers, computational fluid dynamics. So what we have is, when you do your basic course in fluid mechanics first, you learn many things which are sort of pen paper based or small programming you do. But if you want to do large scale things, then CFD is used. So we have electives in CFD. So there are, when you come to third year, fourth year, you can take electives and then learn CFD, or you can take a project. So for example, last year, my MTech project student was looking at CFD for a mixing of non-Newtonian, given that I said I am involved in complex fluids. So if you have lubricants and some other materials which are much more complex from the viscosity point of view, how do you mix those as opposed to just water and oil kind of system? So we were trying to do a mixing unit and a full scale simulation of that. So that is done using CFD. Yeah, you had a question. Yeah. Right.
One is when we have a curriculum that both courses and electives and someone who wants to stay in the board and not in the venture outside of it. How much research opportunities are provided at an undergraduate? And what I mean by that is, professors have the flexibility to give projects to
Yeah.
students, real life problems.
Right.
One of the things I've heard that in IIT Research Park or the Innovation Center, that it's more for MTech and PhD students as opposed to undergrad students.
No, I think it's for everyone, but yeah, please go ahead, complete your thought. Yeah.
Essentially, I think all of this, we have to go for higher
Right, yeah, yeah.
in chemical,
Yeah, yeah.
Purdue or something,
Right, right, yeah.
research.
Right.
Projects you've done really matter.
Right, right, yeah. So I can just answer sort of again to what he said, but it will answer maybe in part to what she was expressing. So one of my advisees came just last week or 10 days ago, because in his scheme of things, he needs to decide whether he should apply for internship, which is basically for industries, but he sort of had made a decision that he wants to do MS PhD. And so, if I do internship, then it's a slightly different path, because then also he's worried about, because see, if you do take internship offer and then say no, it's not good for the institute. So therefore, he's thinking aloud. So he came to me. And so through the talk, then we finally came up with, I gave him this suggestion that if he's very keen on the MS PhD option and he's quite clear, then it's okay for him to try an internship in a research place. And that research place can be IIT Madras or other places also. And so then he went out and then he wrote to me saying that it's very clear now, he's just going to try that. And so short and long of it also, he then approached already 3-4 faculty members at IIT Madras, and he's quite immediately agreed also that, okay, I can give you. So therefore, in general, students can always approach faculty member and get internships of this kind. But institutionally also, to involve undergraduates in our research, we have included things. So we have, for example, what's called undergraduate research program. So instead of doing course and getting X number of credits, you can actually enroll with a faculty member and get some credits instead of doing a course. So this is one way of, in fact, even formally getting credit by doing research. We have also something called Young Research Fellow Program, where again, where again institute encourages undergraduates to take research. This is over and above, students just approaching faculty member because they have learnt a course with them and they're just saying that, okay, I want to be here in the summer and do work. That's quite common. Yeah.
And also to add on to that, it is not specific to chemical.
Yeah.
It's also not like MTechs and PhD are the only people going into research. If the student is interested enough in research, they can always approach professors. Professors are very friendly and welcoming, and they could always research on things whenever they're free. Our curriculum provides that flexibility for us as a BTech.
It so happens, at least in my personal experience, that it's the flip side which is little more true, given the age group that undergraduates are. So every time I say yes to an undergraduate intern, I also tell them that I have had 1 in 3 success. In the sense, many times because research involves being down, nothing is working out, nobody is helping. So you reach that kind of a stage. And so there are only 1 in 3 who say, okay, no, I must overcome this at that age, because there are 100 other things. So 2 will say, okay, nothing is working out, I'll leave it. So that's also there. But it's okay. That's part of the learning process. Sorry, the question is not clear. Can you? Yeah. What about internships?
Internships, like, do we have within IITM or we need to go?
No, that's what. So internships means all of different things. So it is to different industries. It is to different research institutes within India. It is to research institutes abroad. All of those things. Internship in startups, because let's say there are IITM startup who also give internship to their own students. So therefore, internships can be in any of these things.
Can you suggest some companies, because like I'm not from this department.
Yeah, no.
So I don't have any
Some of
idea.
these companies will also take interns.
Internships.
Yeah,
Okay,
yeah,
okay.
they will take interns also. In fact, these days the students are worried a whole lot about internship for the reason that many of these companies take intern and then convert that into an offer. So they have a term called PPO, pre-placement offer. So it's a fairly big thing, because they feel that if let's say job is their first number 1 priority, then to get a good internship and then hopefully get converted into job offer will mean that things are relatively already defined for them. They don't have to worry about. So internships are common in many of these industries. They're common in universities all over the world. See, given the reputation of our institute and our undergraduate programs, from all over the world also people would want to offer you internships. So students go all over the world also for research internships.
I have a question.
Yeah.
May I know, like, what percentage of students are moving into oil and gas from chemical engineering department?
Percentage will be difficult to say, but so in oil and gas, would you also include petrochemical and refining, or you're only saying oil exploration? Upstream, okay. So that is a little less fraction. If you look at also this, what is flashed here, what is happening is many of those roles are more from MTech and PhDs. I don't see ONGC, for example, coming and hiring from our campus, though IOCL and HPCL do come.
Yeah.
So.
In the earlier days, ONGC was recruiting
Right.
But I'm wondering about the current status, like how it is going.
Yeah, so yeah, I haven't, I'll have to look at the data more carefully, but I have a feeling that maybe it's not as high as it used to be when you were there, but I may be wrong also on this.
In a way, ma'am, right now PSUs have stopped coming to IITs or any institutions as such, and they are generally taking through GATE. So you give GATE and they will provide you, like they will take an interview of you. That's how PSUs are going right now. So they're not exactly directly coming to the placements, as in because BTechs as such go into the fourth year and decide that they want more package than anything. So their companies have returned empty-handed quite a lot of times, and
Yeah.
they've decided that they don't want that.
Also to add to sort of, see, this is how sometimes it's very difficult to make up mind as to what is the, let's say, IIT Madras about. So though I gave you an answer that maybe not many people go, but IIT Madras as a research institution, if you look at our worldwide that QS ranking, our in petroleum engineering, which includes upstream and downstream, we are the in top 50. So therefore, as an institution from Department of Ocean Engineering, there is a couple of colleagues in our department and then others who are working on various aspects of oil exploration, enhanced oil recovery, and so on. So therefore, IIT Madras is making a huge contribution. But whether undergraduates are getting employed, that we need to look at the data more carefully.
But I remember like ONGC is one of the Maharatna company, and they prefer going to IITs.
Mm-hmm.
And I think it is they are going to IITM Dhanbad and IIT Dhanbad and RCIPT.
Mm-hmm.
So I was wondering like how is the status with IIT?
Yeah, we'll have to take a closer look at the data. I'm not sure, yeah. Okay. Okay, then. Yeah, sorry. Yeah.
One more question. The Shell you have mentioned,
Huh.
here, is it the one, the Shell here in Chennai or?
No, these are global. Yeah. So they have an R&D sometimes. They have, yeah, Shell lubricants is also there, yeah. Pardon me?
So all the kind of statistics and data you can actually find on AskIITM website. You can enter AskIITM website, and there is a detailed data of placements for not just chemical or any other branch. There is for every other branch, and you can also see the distribution of core, non-core placements. Please do check out that, and you will get to know a lot about it.
See, one of the things that I can make a little stronger pitch for chemical engineering here in a very indirect way. I'll say that when you look at the averages, whether it's in terms of salary or whether it's in terms of percentage placement, we always wonder that why in the scheme of parents and students, we are not, that preferred. Because numbers, data suggests that these are definitely much better than the kind of ranks and other things that we get preference for. So I think there's never to, we are definitely doing better than what the ranks and other things suggest where chemical engineering is. And you can see the names of companies here, right? I mean, they're very central to right now economy and everything else that goes on. So therefore, pay package, like what you said, will definitely is going to be, on average, better than some other disciplines.
Is there any special subject in chemical engineering more focused on reservoir engineering or reservoir fluid mechanics, something like that, sir?
No, not currently. Yeah. So we used to have a petroleum engineering MTech program being run from ocean engineering, which had and also ocean engineering have faculty members who are in geology and that kind of background, which have more expertise in these kind of things. But as chemical engineers, we learn sufficient things about porous media and flow through porous media, so we can communicate with each other. Yeah. But we don't have a course specifically on reservoir engineering. Yeah.
We were on a campus tour, and one of the IIT students was sort of pointed out the fact that like ocean engineering is sort
There's a building itself, yeah.
of building, so there are only BMWs parked outside. Outside computer science, the market is the grants, most of the grants seems to be coming from biotech and ocean engineering and maybe chemical.
Actually, maybe it's a, yeah. So in terms of sponsored research, actually, it may varies. We are talking, of course, employment and those things here. What you're talking about is within IIT. So within IIT, it can vary, right? So for example, ocean engineering is the only one which in the country. I mean, there's IIT Kharagpur has, so therefore it has a very specific place. And so, yeah, some of the other data that you're talking about could also be just current personalities and current, people who are there and things like that. Okay, yeah. Thank you, all of you, and all the best to, all the students who are here and the parents.